Well, welcome everybody to our March edition of the ABA Engineering Academy's engineering webinar series. We do these every month on the third Tuesday of the month, so we'll mark your calendar for all those dates, so you can join us every Tuesday or every third Tuesday. We have a very special presentation today. Before I introduce our guest, though, let me make a note here that the webinar is actually underwritten by Max Connect Group. If you haven't checked out the Max Connect, go to www.maxconnect.com and take a look at it. It's a nice little device that you can use for STLs or remotes and using the Wi-Fi, and it's a nice unit. So check those out if you will. Today we are joined by Kirk Harnack with Telos Alliance, and he is actually at a well, he's not there yet, but he's in Atlanta, and he's going to be attending in a little while. He's going to be attending the WSB AM 100th anniversary, I think. Is that correct, Kirk?
That is. They got their first authorization from the FCC on March 15th, 1922, 1 year ago today.
That is
100 years ago today, sorry.
Oh, okay. And what's all going to be taking place there?
I'm sure there'll be some jokes told and transmitters admired and barbecue eaten.
I'm sure there is. But well, you can go ahead and get started with your presentation, because I know you can probably smell the barbecue from where you are. So just go ahead.
All right, let's get it shared here. Let me share it up on the screen, and let me know when you see my first slide.
I got it there.
Good deal. Okay, I'm going to try to get my cursor out of the way and make sure everything's nice and clean. Hey, welcome in, everybody. I'm so glad that you've joined us. I have actually just finished putting this presentation together. I've been working on it for days and days. Well, okay, honest truth be told, I've been working on it for 15 years because it's about troubleshooting audio over IP networks. And so I will roll into it here in just a second, but I will tell you that this presentation, we're going to have a fair number of video clips from my friend and yours, Chris Tarr. Chris has been using audio over IP for quite a few years, and there's so many things that other people say, I think, better than I do. And so I got Chris to contribute quite a bit. Also got Brian Jones, who's one of the support engineers at Telos Alliance. I got Brian. Brian was actually, frankly, he was too busy to get on camera, but he gave me quite a few tips and other things that, loaded my lips with some information. So we'll start this right now. Look forward to a fast-paced thing, and at the end we are going to summarize everything. So if you stay to the end and keep get a pad of paper and have it handy, then you can jot down some of the tips and ideas that we present throughout, because we'll summarize them at the very end. All right, so here we go. Hey, broadcast engineers have known how to troubleshoot, and at several levels. We understand systems level, equipment level, and component level troubleshooting. We can also take an educated guess as to when the equipment is maybe simply being used incorrectly. Well, audio over IP, and I'm going to refer to that as AoIP, audio over IP, for broadcast facilities is now approaching its 20th anniversary. Can you believe that? Yet troubleshooting AoIP networks and systems actually remains a little bit mysterious for many engineers. And the techniques for identifying, locating, and fixing trouble are different than for legacy audio systems. Well, different in some ways, the same in others. Now, this presentation is going to introduce the concepts and techniques that broadcast engineers need to know in order to maintain audio over IP networks. We're going to demystify some of the critical aspects of multicast audio. We'll examine packet handling and prioritization, and we'll cover the most common faults that lead to audio problems in AoIP networks. So here's Goofy me, the Senior Solutions Consultant at Telos Alliance, and my goofy partner friend, Chris Tarr, Director of Engineering at Magnum Media. I happen to know that he's at a transmitter site today, so maybe he'll catch the replay of this presentation. Finding the source of trouble in our legacy radio stations seemed pretty straightforward. With point-to-point wiring, we just simply started at a point where we knew that the audio was good, and we worked our way toward where we knew it wasn't good. Some shortcuts have always included the divide and conquer technique, in which we pick a midpoint of the audio path and we check there. And then we move upstream or downstream, again, dividing and conquering, as indicated by our test results, and at each midpoint that we would check. Well, PCs and networks have introduced a new level of complexity and sometimes frustration. For those who learn the fundamentals, most problems do become solvable very quickly and without resorting to a baseball bat. Audio over IP networks are different, and they're also a bit similar, though, to legacy audio or even AES EBU digital technology. And AoIP networks are fairly similar among themselves. That is, the different brands in how they work, whether it's Dante, WheatNet, Livewire, Ravenna, AES67. No matter which brand or flavor of AoIP you're troubleshooting, all the big players have got to operate in the same standardized network environment that are used in the IT industry. So there's got to be a lot of similarity. Standards like UDP, RTP, NTP, HTTP, TCP, and other low-level protocols like QoS are typically employed in AoIP networks. And they all share this some kind of clocking protocol. They deliver digital audio in packets. However, all AoIP systems absolutely do expect 100% packet delivery, with each packet arriving in a timely and orderly manner. Unlike audio codecs that are meant for public internet transport, the popular AoIP systems expect perfect packet delivery, hundreds or even thousands of times each second, and for each audio stream on the network. Now, Chris Tarr, Director of Engineering at Magnum Media, describes here some differences with troubleshooting AoIP networks compared to legacy audio systems.
Audio is audio, so what you hear is what you hear. So in that respect, it's very much the same as analog audio. However, because the delivery method is so much different, it requires an entirely new mental and physical tool set in order to troubleshoot these things. You have to have a knowledge of TCP/IP, of UDP, of broadcast packets, of routers, of networking, of all of these different things, because there's two levels to this. There is, obviously the audio coming in and the audio going out. How does that sound? Is it something before it even hits the Axia network that sounds bad? Is that what you're hearing? If that's not what you're hearing, then is it somewhere along the Axia network? So it requires, some of the old school and some of the new school, because audio, again, that doesn't change. The sound of audio is the sound of audio. And if, they have the old saying, garbage in, garbage out, and if the audio going in is bad, Axia can't fix that. It's going to come out the other side sounding bad. But if it's jitter, or if it's something in the wiring, or if there's errors and packet collisions and things like that, then you're going to have to lean on knowledge of networking in order to troubleshoot that. So it's a little of this and a little of that.
And by the way, through the presentation, you're going to hear Chris and me refer to Axia and Livewire. But most of what I'm saying refers to any AoIP network, just that I'm most familiar with that because I'm employed by Telos Alliance, and Chris has a number of Axia systems himself. But the techniques are pretty much universal. There are common symptoms of improper operation that we want to look for or expect. Maybe there's no audio on a channel that you're expecting audio on. Maybe there are pops or clicks or dropouts in the audio. Maybe the sync indicator on a piece of equipment is flashing or intermittent. Maybe the live wire source advertisements are missing. Maybe there's bad audio after a power cycle of an Ethernet switch. So these are some of the common things that you might find. The AoIP network, and this is from Brian Jones at Telos Alliance Support, the AoIP network doesn't pick on or bully one audio channel, the network itself, that is. A problem with one channel only, is likely a problem at the source or possibly at the destination. It's likely not the network. So if you've got 200 audio streams, channels, if you will, working properly, and there's one that's not, it's probably not a bad cable or a bad connector, unless there's just one cable responsible for that one source. So just to set some expectations, Chris Tarr describes his own experience regarding the most common AoIP system faults.
Generally, it's going to be networking, either, network cables, network routers, network switches, those sorts of things are generally going to be the biggest offenders in what you're going to find. Then secondly is going to be the audio over IP drivers in the computers. And the reason I say that is generally those are the things that aren't in the ecosystem of audio over IP in Axia. For example, if you just had an Axia surface and an engine and that was it, it would work fine and it would continue to work fine forever. But when you add in these other things, Axia can't account for every possible configuration everywhere. So for example, if you get a non-supported switch, or you have a switch that isn't configured to work optimally with Axia or the Livewire packets, you may get audio dropouts, you may get delay, you may get jitter. Same thing with using a Livewire driver on a computer. The firewall on the computer may affect the audio coming in and out and completely stop it. Antivirus software. So, those are the kinds of things you got to think about when troubleshooting is, obviously you start with the low hanging fruit, but then, keep in mind that it's not necessarily the Axia or Livewire gear that's the problem. It could be anywhere in between there, and it could be something that has nothing to do with Axia directly.
So how do you start determining? How do you start looking? Where do you look for? You're called in. Hey, there's a problem with this automation system playing out on the console. What's wrong with it? And you may walk in and you may feel like this guy. You feel, well, look, where do I start? Oh my gosh, where do I start? Well, let's look at where to start. Again, determine, is the problem a single audio channel, or is it all channels, or maybe all channels from a given device? Is the problem intermittent? Was it there yesterday? Is it gone in 5 minutes? Is it intermittent? And does that channel, this is important, I think, does the channel actually sound good anywhere? Is there any place you can find where it sounds proper, sounds good? Because if it sounds good at one place, at just one place, then you know that, the source is probably not the problem. So you can eliminate that as being a problem if it sounds good at one place. And that's a lot of standard troubleshooting. So Chris Tarr here now describes his own general rules for beginning to find a problem.
Generally, you want to work backwards. So you want to start with, is there any place in that chain where it doesn't do that? And then work backwards from there and figure out where that audio stuttering or those impairments start. Generally, with working with audio over IP, that stuttering or clicking is usually something in the networking. So packets aren't arriving in time, they're arriving corrupted, there's no synchronization or lost synchronization, something along those lines. So really, one of the benefits of Axia and Livewire is you can narrow down by bringing up each path that audio takes and bringing out each hop that audio makes and giving it a listen. So for example, if you're listening over the air and you hear the audio over IP stuttering or dropping out, you can work backwards. Okay, here's the output from our EAS box. Here's the output from our processor. Here's the output and you can work back until you no longer hear those stutters. And if you go all the way back to the control room, to the surface, then maybe there's an issue in the engine, or maybe even farther than that, it's a Livewire driver on a computer. So it's that kind of troubleshooting is the same as you would with analog. You're just listening for different things, so you just keep working back through each patch point until you no longer hear the problem.
One way to start troubleshooting is, of course, to listen. We're in the radio business. That's what we do. It's very convenient and a great reference to have a piece of AoIP hardware that allows for quick selection of a network audio source and connecting that audio output to speakers or headphones. An unused output on an X node may be used as well, though you'll need to keep a PC to control the source selection. So on your screen here are some devices that I use to do troubleshooting. The top one is from Axia. It's called the X selector. You can pre-program up to 6 buttons, and then you can select anything on the network with the knob on the right. It's got a headphone jack in the front. The next thing down in the middle, that is the original X selector from Axia. Actually, that's the one that I've got in my office. It's a pretty old piece of equipment, but it works great. And then if you don't have either one of those, although I do suggest that you get an X selector for your rack room, if you don't have either one, you can use an unused node output, an analog node output, and feed a headphone amp or feed some speakers. But from the front panel of the X node, there's no way to select what the output is going to be. So you'll need to use a browser. You can browse directly into the X node and select what channel you want to listen to, or you can use some software like Axia's Pathfinder PC, or there's actually some free software out there on the market. This is an example of the Livewire Simple Delegation Switcher. You build your own button panel. Now, another way to listen, and because I live 6 or 7 hour drive away from my nearest radio stations in Mississippi, sometimes I need to do some troubleshooting by listening remotely. Another way to listen to different network channels is via remote streaming. Now, I don't mean a live wire streaming over the public internet. You can't do that. But I do encode an AAC stream, a private stream, and listen to that. So with troubleshooting remotely, you can direct an AoIP channel to the input of a streaming encoder. And you have the streaming encoder set to create a private, high-quality audio stream that you can listen to remotely. And then you direct whatever AoIP channel you want to that encoder so you can have a good listen remotely. And this is the panel that I built up to send all kinds of different things into my test stream selector in Greenville, Mississippi. So you can see I got various channels there. I say post EAS for different radio stations. I can listen to a number of the different satellite receivers directly, listen to a few of the tuners off the air. So there's a lot of things that I can listen to remotely that way, and that's helpful. And I can add a button if I need. If I need to listen to Jock's mic, for example, directly, I could do that. Well, most of us are not as excited about statistics as Kermit is here, but we recognize that computers and CPU-based devices are really good at keeping track of things. So it is with networked audio equipment and software like IP drivers. The stats that they produce can tell us a lot if we just will have a look. So in troubleshooting AoIP network problems, we're going to be very interested in the statistics data offered up by that networked audio equipment and software. Most any AoIP gear from any manufacturer is going to have a page of network packet statistics like what you see right here. The large graphic in the background, that is from an Axia IP audio driver running 16 channels of audio. Actually, it's subscribed to about 10 different channels. And then in the foreground, this is a page off of an Axia X node. And it tells you things like the software version, the temperature, whether the sync is operating or not, which network connection is working, and even the uptime. Look at that. That one was up 199 days. I guess that's the time since the last power outage at that group of radio stations. When coming upon a problem in an AoIP network, there are a couple of things that are easy and quick to check, and they tell you a lot about the general health of the AoIP network.
Well, the first thing I always do is I look for sync. One of the great things about Livewire is you can see whether or not the clocks are synced. And if you go to the software, you can see how well they're synced. So generally what you'll see when things really go haywire is generally a loss of sync on all the different nodes and all the different devices. And when that happens, that really does point to the network switch, that it's not passing those packets fast enough or in the way that everybody's expecting. So, rule number one is you should always have a spare network switch available so that you can use that in troubleshooting. But, it's that old adage. It's like if one thing has the issue, it's that one thing. If everything has an issue, it's something that everything is combined through, and it's always going to be through that network switch. So it may not be the switch, it may be a cable, but again, that's where good networking education starts. You can log into the switch. Are all the ports set for trunk port that should be trunk ports? Something simple as rebooting the switch. If it worked fine before the power outage, when you reboot it, does it work again? But again, Axia gives you a lot of tools to check that in the Livewire domain. How is the timing working? Where's the timing coming from? What clock is master? Is that master clock having an issue? Does that master node have to be restarted? So, those are the things you kind of have to look at when you have an issue where it's affecting everything. It's a global sort of thing. You're going to find one common device that's having the issue, and it's kind of propagating to the rest of them.
Chris mentions checking for good synchronization in the networked audio devices. Now remember, if the device can't sync to the network clock, well, it's likely there's some network or equipment problem that needs to get solved before good audio can be received. In an Axia network, any properly synced X node will have a steady sync indicator on the front panel. You can also check for good sync in the web interface. one of the devices on the network should be the master clock. And in that case, the indicator will say master. If the sync indicator is blinking, then synchronization is not reliable and the cause needs to be located and fixed. And this is true for any other network that I'm aware of. They all have to synchronize to some master clock. Now, because computers have a lot going on that's beyond your AoIP manufacturer's control, there's some extra suspicion surrounding any PC's network operation. Properly configured, a PC can work perfectly on an AoIP network for its entire life. However, software OS and driver updates, as well as other factors, can be troublesome. Here's a well-working IP audio driver showing a low amount of jitter. 1491 microseconds is what it showed there on the screen. This UI also shows how much clock adjustment the IP audio driver is making to the PC's sound system. In this case, 0, so it's in good shape. Also shown are the number of times that sync was lost and the number of packets received since the last reset. The clock source IP address is also displayed, so that would be the IP address of whatever live-wire device was providing clock. And also the multipass group address of the clock signal is there, because clock is multicast. Note that the reminder there that jitter is a good figure of merit and it must be under 25,000 microseconds. And there's a reason for that, having to do with the Windows own clocking mechanism and how much time goes by before it goes and addresses some audio, which I think is about 30,000 microseconds. So 25,000 is the most that we're comfortable in putting up with in terms of jitter. Here's an example of where to check for clock sync on, let's say, an Axia QOR audio mix engine. You can use either a browser or you can check the sync light on the front panel to see if there's sync there. Now, while you're in the QOR mix engine, you can also check all of the live wire packet stats. In the QOR, and I don't know why, but for some reason it's not linked on the main menu page, but you can type in the address of the QOR in question that you want to go look at, and then /debug/LWIO for LiveWire IO. And you'll bring up this page, which can show you the LiveWire streams that are coming in, the LiveWire streams that are also going out. It's elsewhere on this page, and you can see the packet stats there. The ID of the stream, for example, how many packets are buffered, which is typically going to be 20 packets for standard streams, and typically it's going to be just 1 packet for a live stream. That's where your microphone or other live stream device will be coming in. In this case, if you see on the screen there, the third item is stream number 6001. I happen to know that that is the telephone hybrid from a Telos HX6 phone system, and it's capable of producing a live stream, and so it's received as a live stream on this QOR in the control room. So just 1 packet there, so we get minimal buffering delay from there. So there's all kinds of things. You can look at overruns, underruns, timestamp defects. It turns out that those are all looking really good. Now here is actually a LiveWire driver running on a Windows machine. And this particular one had not been checked in weeks. And you can see that the jitter had crawled up to, or had at some point spiked, up to over 30,000. Things happen when you're not looking at a network, and maybe even when you are looking. This driver shows the highest jitter number it has measured since the last reset of that parameter. Often when checking on this, you'll see some fairly high number for the jitter count. Make a mental note of that and then click on the clear jitter button and see what it currently is and see if it's climbing up, see if there's a problem with it going on up. In this case, I clicked the clear jitter button and it dropped down to 2,186 and didn't climb up much after that. So jitter can happen. Jitter is a combination of the jitter being received and whatever the jitter is in the measuring mechanism inside the PC, and that has to do with the driver. So if the host PC is pretty busy, well, your jitter may look high when in reality what's coming in from the outside may look low too. But this is the jitter that the system will have to deal with. The Axia IP driver will have to deal with. The IP driver here is showing an enormous high jitter number, Probably a one-time hit caused this anomaly, but I'll point out that this driver you're looking at right here, I screenshotted this. This is actually running in a Windows virtual machine. So this machine is not running on the bare metal hardware. It's virtualized inside of a Linux machine. Adequate resources, well, you need to make sure that adequate resources are allocated for normal operation, but contention with other VMs can certainly cause a spike in response time as measured here. And you can see there's quite a few driver underruns, overruns, and sequence errors, and that jitter number is crazy high. So what are we going to do about that? Underruns, overruns, and lost packets. You may feel like this guy at the weekend at a Super Bowl game a few years ago, and say, "Where am I going? How do I get there?" All right. Clearing that jitter counter brought that number, that super high number, back down to a much more respectable 10,611 microseconds, which is still well under 25,000. But it is higher than you'll find on a machine that you're running on hardware. So again, this is a virtual machine. We also cleared out the packet error count, and we're not seeing any more packet errors creeping in, at least not for now. So that is I want to point out, that is a danger. And I've got to tell you, this particular machine this Windows machine running in a virtual environment, I can't say it's been properly optimized. It's been optimized a little bit, but I think it probably could be optimized better. But such as it is, it's one of my stations in Hawaii. Now, many AoIP users, whether it was Axia or other brands, they had a real problem with their IP audio driver after a Windows update back in 2020. Some of them, the computers waited till 2021. Microsoft, back a year to 2 years ago, made a fundamental change in the Windows kernel sleep timer. So if you have an AoIP system, whether it was our brand or another brand, you may very well have had a problem with much higher jitter. Now, this sleep timer has nothing to do with the PC going to sleep, but it has everything to do with CPU task switching, this real fast task switching. This change by Microsoft caused a lot of trouble for many near real-time processes, and this was particularly noticeable with live audio. Developers at Telos Alliance worked with Microsoft engineers, and a workaround was discovered whereby the IP audio driver can instruct the kernel to revert to its previous sleep time interval. Now, the main point here is use your manufacturer's resources to update your equipment and software as necessary. Don't be afraid to talk to your support department. And as a general rule, I don't like for my on-air PCs to be doing updates. And in fact, it was typically production PC machines that are used for internet access and other stuff that were affected first by this, that went ahead and did Windows updates. This, by the way, the screen that's the screenshot that's on right now, this is shot from a page at a very useful website. You may want to jot this down. We'll give it again later. It's support.telosalliance.com. And this is it brings you to basically a search page on the support side. And you can type in a plain language question, and you're pretty likely, there are literally hundreds and hundreds and hundreds of help docs, help articles there, and you're very likely to find an answer for Telos, Omnia, Axia equipment there. You're very likely to find an answer for the problem that you're having, because the support guys have taken all their most popular questions and made support docs about them. So waiting in line for a support engineer, no waiting for a return email. You can go look things up yourself, and there's a good chance you'll find the answer to your question. And if you don't, the usual email to support at Telos Alliance or the phone queue can work as well. But check that out; works well. All right. When troubleshooting some audio problems, it's easy and convenient to point a finger at the thing that you can't easily see or see into. And that's the AoIP network, because we can't really see the packets flying by. We don't know what's going on. Even if we could, they're very fast. From my own experience, and which is about 15 years of AoIP experience, when being made aware of some audio problem and the suggestion is made that it's got to be that Axia network, and again, replace Axia with anybody's network, truly I've found that nearly 100% of the time the problem hasn't been the network. It's been something else, and that's not just pride talking or because I work for Telos and Axia. That's been the actual case. If there's a PC involved in the complaint, well, the problem is almost always there. However, sometimes a fault can be attributed to your AoIP network. It can actually be in a different piece of audio hardware. In other words, you may notice the fault like in an audio console, but that's not where the problem is. So Chris Tarr explains about that.
I had an issue where I heard dropouts in the audio, and I swore up and down that it was Axia and Livewire, and I was like, I couldn't trace it. Everything was synced perfectly. Nobody else was having the issue, but I had the one station where it would just give me these little blips, and I'm going, the thing is just going through Axia through Livewire from beginning to end, so it's got to be Livewire. Well, I backed up and realized that there was one hop where it went from AES out of the node into AES in on the EAS encoder and then back out. And the encoder, the NDEC, was the one that was losing sync and causing the audio to get choppy. And I never in a million years would have thought that, but with Livewire, I was able to do that, where I started at the transmitter side and worked backwards until I stopped hearing the dropouts. And it turned out it was right before it went into the EAS encoder.
Another aha moment is relayed by our support engineer, one of them at Telos Alliance, Brian Jones. One AoIP network was particularly troublesome with intermittent problems, and the network was large enough that it used 2 good-size Ethernet switches as its core, and these were connected by Cat6 cable in a trunking arrangement. Well, it turned out that this cable used for tying both switches together itself was intermittent. Replacing a $5 cable made everything work reliably, but I'm told that it was a little bit difficult to find because it wasn't suspected. You don't suspect a 2 or 3 foot long cable connecting 2 pieces of equipment that are right next to each other, and yet it turned out that was indeed the problem. And so that gets to my mantra: suspect the simple things first. And the number one thing I suspect first is cables. The number 2 thing is cables, and the number 3 thing is also cables. The number 4 thing is connectors, and then 5 is connectors, and the 6th most important thing I suspect is connectors. And then I ask, is it plugged in? And then I ask, is it plugged all the way in? And that's come about because these RJ45 connectors, if they're a bit malformed, if you made one yourself, or even if you bought them already made on patch cables, sometimes they don't quite go all the way in. There's a plastic boss. There's something that wasn't right about the formation of the connector, or the little plastic clip that holds it in may not be holding it in well. You know how that works. If it gets twanged back at some point from being pulled backwards, it may not be strong enough to hold that cable in. I've had that bite me a number of times. Or even the little rubber shroud from the strain relief that sometimes can go over the plastic catch. Sometimes that can interfere mechanically with the catch actually catching in the RJ45 jack. So yeah, is it plugged all the way in, and is it stable? Is it going to stay there? Tug on it. Make sure it's not going to come out, or come out even just a little bit. It's got to be in there firmly. Those connectors are gold plated. They work great when they're mechanically solid together. Thinking about our favorite tools to help us troubleshoot our AoIP network, Chris Tarr has some thoughts about tools for Dante and for Livewire.
I would say in terms of Livewire troubleshooting, each thing is different. Dante has a different software, but for example, iProbe for Axia with Livewire is an unbelievably handy tool to see what's on the network, the IP addresses, what channels are assigned. Dante has something similar with their drivers where you can see cross points with Dante, but anything that allows you to see what the network sees is really handy, because you can all of a sudden tell, okay, this device isn't talking to anything else on the network, so I should see it there, and I don't. Or in some cases with iProbe especially, I've seen that where, it'll show up, but it won't show up completely, which means that some packets aren't getting through or those sorts of things. And you can listen to the audio that's out there, that's on those devices. So I really don't even dive into any kind of substantial Livewire project without that software, because it just really cuts down the amount of time that you have to spend digging up IP addresses of devices and things like that. So I would definitely say a computer and additionally software on that computer to look at the network.
Now, Chris Tarr mentions Axia iProbe as a valuable tool for troubleshooting a LiveWire-based AoIP network. iProbe is software from Telos Alliance that can document most LiveWire functions, especially discovering the devices on the network. It can report on the current firmware version for most Telos Alliance equipment and even advise on new firmware versions that are available for download and installation. iProbe can also create and save a snapshot of the devices and the multicast channel numbers that are in use. You can save this info. That's helpful if equipment resetting or replacement is needed at a later date. iProbe also allows listening to LiveWire channels through the host PC. In other words, the PC that you're running iProbe on. It can open a framed browser also within the context of iProbe for convenient viewing and control of any of the network devices that have a browser interface. And other brands of AoIP network systems may have their own tools to do the same thing as this, to monitor and document the system. So check with your AoIP network manufacturer and see if they have something like that. So here's a list of tools that I find particularly helpful. As Chris mentioned, Axia iProbe for LiveWire networks. Probably one of my most valuable tools is just a known good computer on the network. Because you can tell a lot just by going to some computer that's on the AoIP network. Maybe it's a production PC that's not being used at the moment. Maybe you want to bring up a browser in one of the automation PCs, or maybe you have your own laptop that you can plug right in there. Because you can browse into all kinds of different devices and look at the stream statistics. You can do network pings to see if things are responding or not. You can do firmware updates on network devices. So just a computer with a browser just works great, and it's very valuable. And that listening gear we talked about earlier, an Axia router selector node or an X selector node or any node output. And of course, that applies with other brands too. If you have a WheatNet system, then you can use a blade and an unused output on a blade to feed some speakers or feed a headphone amp and take a listen. And that website, support.telosalliance.com. Again, it's the front search engine, front page of it, and you can just type in a plain language question. Of course, I mean, it helps to kind of know your search terms, but plain language questions do seem to work pretty well. Here's some advice. Keep any non-AoIP devices off of the network, especially consumer devices. And please, no Wi-Fi devices on your AoIP network. That's trouble right there. The barrage of broadcast data on an AoIP network can overwhelm and cause trouble with non-qualified computers and Internet of Things devices. Light bulbs, right? Those Hue light bulbs, or even just a consumer grade network switch can be overwhelmed by what's going on an AoIP network. So switches and routers, make sure they're configured, they're qualified and configured for being in a multicast environment and on a media network. So keep that special. Now, since the AoIP network is critical to on-air operations, Chris Tarr says there's a couple of things he does at each of his facilities to help ensure that they keep working and that troubleshooting actually is easier if something does go wrong by initially doing a couple things.
I have two very important things that I do. Audio over IP traffic has red cables. Red means don't touch. Red means danger. If you mess with this cable, you're going to cause a problem. And then the IP addressing scheme really is a big one because you're going to have to go back sometimes in an emergency, sometimes under pressure, and look for these devices. And so I always use an IP address scheme that identifies the station, and then from the station, each device. So, for example, Studio One would end with .10. Well, then, would be the 10 group. So the engine would be 10, the node would be 11, the computer would be 12. And then the same thing, 20, 21, 22, 30, 31, 32. And that way, okay, station B is having an issue and I need to get into their surface. Okay, so that's going to be station 3 is .30. So 10.1.10.30 or whatever, and I'm in there. And that saves so much time when you're under pressure to get in and take a look at something where you're not having, oh, what's that IP address? I got to look that up, or I need to scan the network to find the IP. If you are consistent with your IP addressing, especially as the Livewire network or the audio over IP network grows, it's going to be a lot easier to find it later on. And then again, with the network colors, you can say you can pull anything, but anything except anything that's red.
Yeah, well, Chris Starr provides a summary list here of go-to troubleshooting tips when the packets aren't flowing smoothly. And by the way, we'll have this written down in text form in the next few slides, so stay tuned for that. But here's Chris's home list.
But obviously, cable is a big thing. I've had even pre-made cables fail right out of the box. So always have cables sitting around and available for testing, because that's the easy first thing to do. And also, you kind of get a feel for it. I mean, if a device is completely offline, I would go for the cable first. But it's amazing how many little errors are caused just by intermittent issues with the cable. So cable is usually my first go-to. The second is common network things, pinging the device. Does it ping back consistently, or are there dropped packets in a ping? Again, if you have a selector that can select audio on the network that you can listen to, even better. If you have a computer with iProbe on it or iPlay, where you can listen to the audio that's being played over the network, that's very helpful. But a lot of it is just going to be network tricks, because 9 times out of 10, it's going to be something in the network and not a device. Very rarely does a device have that much of an issue where you're dealing with hardware. It's going to be things on the network. Somebody plugged something in that they shouldn't have. So knowing how to use network scanning tools is very helpful in troubleshooting these networks.
In a PC, and by the way, I got this advice from Brian Jones, and I'd kind of forgotten about it because back in the early days of networked audio, I followed this advice. Use a name brand aftermarket network interface card for Livewire. So you've got a PC, it probably has a motherboard network interface, and there's a good chance you're going to take that in network interface and hook it up to your business network, so that computer has internet access. But then you're going to have a second NIC in there that's going to talk to the Livewire network, so you get audio in and out of that PC. Well, when you add that second network interface, you add a good one. We used to always recommend the Intel brand network interfaces, just because they were a known quantity, they were reliable, the drivers were good, and we just had best of luck with Intel brand PCI cards. And here's something critical. Use the NIC manufacturer's Windows driver for that card. Don't depend on Windows to automatically select a driver for that network interface card. And the reason is because I'm told that a certain amount of the computing in for a network interface can be done in software, and the Windows drivers just do that because Windows says, hey, I know how to do this. I know how to deal with this packet stack right here. I can do that myself, and then I don't have to know all about that card. I just have to use it as a hardware I/O. But the better card manufacturers, and I suppose Intel is one of them, they typically have chips on the card that can do that themselves, but you got to use the Intel driver to make all those work. At least this is what I'm told, and it does agree with my own experience. So maybe that is true. But again, don't depend on the Windows automatic selection for the driver for your Livewire card. Go get that yourself and make sure it's the right one for the card. All right, we're getting close to the end here. What have we learned? This is a good time to take notes, screenshots, or this is a good time to say, okay, I'll fast forward this far into the presentation when I watch the replay to get these notes. All right. Here's what we've learned. Listening to the audio is important. What are you hearing? If you're hearing hum or buzz or audio clipping distortion, those are analog problems. Those are not AoIP problems. There's nothing in an AoIP network that can cause hum. There's nothing in that network that can cause buzz, and there's really nothing that can cause clipping either. If you put the audio in, too hot, well, that's an analog problem. But once the audio is turned into ones and zeros, it's not going to change unless you go change a gain structure somewhere ridiculously. There's a lot of headroom, and it's not going to change on its own. Are all the audio channels affected, or just one? Or just the ones from a given source? So you've got a playout system, maybe it puts out 3 channels of audio. If all of those are sounding bad, but nothing else is, then suspect something between the automation and the network. IP network, true network issues, a switch issue, a configuration issue, those tend to affect every single channel, and probably the clock sync as well. Endpoint issues, well, those are caused at endpoints. Remember that, obviously. Bad audio in an AoIP network console, audio console, on one source, well, that's likely a problem back at the source. It's not likely a problem at the audio console itself. Just because you're hearing it there doesn't mean that's where the problem began. Axia iProbe software scans and indicates streams, firmware, presence, etc. So again, we covered that pretty well earlier, but another thing worth keeping in mind. Manufacturers' AoIP gear, I want to say this, I'm going out a little bit of a limb here, but it's been my own experience, and it doesn't matter what brand it is, their own equipment is rarely the cause of problems. Yes, it occasionally can be, but for the most part, if you have an audio problem with the AoIP network, chances are it's a PC that just needs a little kick in the butt reconfiguration, or finding out what's causing, what's taking up the resources that shouldn't be, or it's the actual audio wiring into and out of the AoIP network. The AoIP gear is really good at taking exactly what you put in and spitting it out in one place or 1,000 places or whatever you want automatically, and spitting out an exact copy of what it received. So if that audio is bad, you're probably giving it bad audio. Check the easy stuff first. Packet statistics, clock, and jitter, and that can lead you to cable or connector problems. CAT cables, RJ45 connectors. Try restarting things. Yeah, I know that's cliche. Reboot it and see what happens. Also, if you have a PC that you don't want to restart the whole PC, there are services, Windows services typically, that are enabling various AoIP functions. You can try restarting those services. Some of those are listed in the help docs at support.telusalliance.com. If you have to, restart the whole PC, of course. Chris mentioned designing your AoIP network with a sensible IP addressing and channel numbering scheme to aid in troubleshooting. And I've always done this myself at my own stations. I would give a range of 10 IP addresses to each control room. And so, for example, my main control room, or the control room A, would typically, the IP addresses for the AoIP gear would end in .10, and would start with the .10, and the last one would be .19. Because 10 was, in every case I can think of, 10 has been enough IP addresses for a given room. Maybe the 20s, the .20s are control room B. Maybe .60s are the nodes in the rack room, and I've got phone systems and codecs up in the 70s. So you can allocate this by a sensible scheme. If you take care of multiple stations, of course, might be easier if you kept those consistent from station to station. So how about the channel numbering scheme? In the Livewire world, years ago, we decided to try to make this channel numbering simple. Instead of you having to type in a multicast IP address for everything you did, we thought, what, we'll let people type in a channel number between 1 and whatever it is, 65,000 and change. And we will algorithm that into a multicast IP address, which Axia stuff does. So you can use that channel numbering scheme to help keep your channels clear. So let's say you have an audio console that's at 10.216.0.50. Well, an audio console could put out a lot of channels. It could. So you need to probably need to allocate 100 possible spaces. If you have a big audio console, I think they can put out up to 70 or 80 channels if you turn everything on. So you may want to allocate, from 5001 up to 5099 for a given audio console. If you have an X node, well, that can only put out 4 things. Actually, it could put out 8 things. Actually, it could put out about 12, 20, 24 things. Yeah, it could put out more if you use all the mixing functions. But for the most part, X nodes can put out about 8 channels. So a range of 10 would work. So I like to take like a .55 X node, channels 551 through 554. would be my channel numbers. And let's say an Omnia Volt. Well, I think it's only going to put out one channel, or if you have a device that does only put out one channel. Let's say my Volt ends at .91. Well, my channel number coming out of that would be 911, channel 911. So that's how I do it and keep things pretty straight, because you don't want duplicate channel numbers. That will mess things up for sure. That's one thing, a slide I ought to put in here is make sure you don't have duplicate channel numbers on your system, because that can't coexist. That really doesn't work well. It's like naming both your twins the same name and calling them for dinner. Well, maybe they'll both come. I don't know. It might not be so bad. All right. Well, it's time for some Q&A, and I see that we have some chat here. Chuck Condren says at iHeart, we separate sites by the third octet. Yeah, that's a great idea. And actually, Chuck, that's what I do as well. Chris didn't make it terribly clear, and I could clear that up. It's the last octet that I tend to separate in by room numbers, or like all my automation systems at one site anyway, are .60. It's 60 through 69. Yeah. And having that third octet, because you have 255 possibilities or 254 possibilities there, so that's good. Do we have any questions, Larry? You master of ceremonies. I don't see any other questions right now, but
yeah, I had a couple of questions myself.
Yeah.
Can jitter occur in a switch or just in the master clock?
That's okay. That's a great question. So jitter occurs, I guess the big answer to that is anytime when a function in a piece of equipment is trying to do something on a regular basis, and for whatever reason it can't do that precisely as you want. And so, a jitter of 0 would be great. But if maybe it's just by the natural count of the task inside the piece of equipment, that it can't do it with the precision that you want. So you may have, a few microseconds, or when you do a ping on a PC, when you do a speed test, it'll show you how many milliseconds of jitter that you have. And if your jitter exceeds the size of the thing that you're sending, then you could have dropouts and problems depending on the buffer size. So if your jitter's high, you could buffer a lot and then eliminate the effects of the jitter, because hey, it doesn't matter how much variability I've got in data coming in, I've got a big supply. Almost like just-in-time manufacturing, right? Let's say you're manufacturing cars or widgets or something, and you've got parts coming in. Well, if you've got a big, huge supply, it doesn't matter if the truck comes sometimes on Thursday and sometimes on Tuesday. It doesn't matter. You've got a big stock of them. But of course, just-in-time manufacturing, you try to reduce your inventory and you try to have a small amount. Same thing in audio. We try not to buffer any more than we have to. For live streams, as you saw in that one screenshot, we'd love to have just one packet buffered. So we need that next packet to come along without fail at the right time. So jitter a low jitter number is important. Typically jitter, if it's caused by the network, there's some bigger problem that's got to be found and addressed. Jitter is typically on the sending end or on the receiving end. It's typically caused by PCs being too busy doing other stuff. That's typically what the problem there is.
Yeah, that was my thinking as well. A couple of comments I had here on wiring on the RJ45. We actually posted on our newsletter that went out yesterday, a link to a video that this guy went through, really a good explanation and demonstration of how to make your own.
Mm-hmm.
And a lot of people do make their own cables and put the RJ45s, and there's a right way and a wrong way. I thought was very interested. He used the pass-through connectors, where you can actually slide the wire all the way out the other end. So one way that the color scheme is right, plus that it's made a good connection all the way through. So that's something I think people that make up their own cables should be very careful in putting on these RJ45s.
Very good point. I'll add to what you said. There's probably 8,000 ways to make them wrong, and probably one way to make them right.
That's correct.
And those pass-through connectors, there's a brand, name brand for those. I forget what it is, but yeah, those are nice. One thing I've noticed is that not all crimp tools are as good as others. I've got one crimp tool. I just do it out of habit. Not only do I just squeeze it once, I squeeze it once and I squeeze it real hard, and for some reason I just hold it there for a second, and then let it go. And I've had much better luck since I've taken more time to squeeze the crimp tool onto an RJ45. My problems with connectors and cables are, I guess I'm kind of good at putting the connectors on, but I have a lot more troubles with the little plastic thing. There's got to be a word for that. There's a not nice word that a lot of people call it. A lot of people call it the little plastic titty, but the little plastic thing that holds the connector in, those can be so troublesome. Or I have had the plastic RJ45 connector just not be quite up to standard, and I got a whole batch of them, and they wouldn't plug in quite correctly into a switch, for example. So yeah.
Yeah, I'm sure that could be a problem. Of course, the retainer clip, if you put the little boot on the back of it, that'll help protect that as well. A lot of people don't put the boot on the back of it, and then the thing, if you flex it back and forth too much, it'll break off.
But there are some of those, the strain relief and the little boot on the back, as you call it, some of those can actually interfere with the retainer clip properly doing its job. I ran across that. Actually, I ran into that yesterday. I was at my office, and this cable kept coming out. Well, the little rubber, the design of it kept the clip from working properly. I had to pull it away so the clip would engage properly.
Yeah, somebody just posted about on the chat thing about a website you can go to look at connectors, I think.
Gotcha.
There's a couple of other questions, I think, on the chat too that popped up.
We'll see. Chuck Connor just made a final comment. Somebody, Scott Phillips, thank you, Scott, posted the link to the Platinum tools.
Yeah,
those connectors.
Yeah, the one I saw yesterday, actually, when you do the pass through, it actually had a blade on the other side. And once you crimped it, it would actually cut off the excess of it as well.
That's how this works. I tell you what, if anybody in the audience here, if you want to invent something that'll make you a gazillionaire, I've said this for years. Somebody needs to invent a box. You load it up with plastic connector, RJ45 connectors, and it looks like a pencil sharpener. It's got a hole in the top, and you take your Cat 5 cable. You don't have to strip it or anything. You take your Cat 5 cable and you plug it in the top. You push it down in the top. It engages a switch, and it goes. And when it's done, you pull it out, and you've got an RJ45 connector properly attached to the cable. Wouldn't that be something?
That would really be great.
You'd be a gazillionaire if you had that.
Well, one final thing here, you talked about always checking the source. You know, in the pro audio area, they always have this thing, get it right at the source. If it's not right at the source, no matter what else it goes through, and as a matter of fact, in digital, if it's bad going in, it's going to come out worse quite often because of the way digital works. So get it right at the source is the most important thing. Okay, Kurt, I appreciate that, and I appreciate that presentation. And
we have one more question here. Eugene Smith asks, in a Dante network, do latency issues create audio issues? Eugene, I don't mean to complain about your wording here, but there's actually a couple different ways I can take your question. I'm not an expert on Dante, although essentially it functions the same way as Livewire and AES67. And latency typically just means delay. And it depends on if you're expecting that delay or not and dealing with it. For example, in the Livewire world, we have a standard stream which has a fair amount of buffering, and by fair amount I mean usually anywhere from 20 packets to maybe or 20 milliseconds of buffering to 100 milliseconds of buffering. Whereas a live stream, we really try to have just 1 millisecond of buffering, or less, actually, come to think of it. So can latency provide audio issues? Well, latency itself just means delay. And if you're trying to talk in a mic and hear your own voice back through a network, whether it's Dante or anybody else's, if there's too much delay there, then it's going to sound weird in your head. And talent doesn't like that, understandably so. So that's why Axia years ago, 20 years ago, invented a live stream, which are very small packets. They're essentially unbuffered, but it depends on the AoIP network working exactly as advertised, working very, very well. And PCs typically don't have enough accuracy to make a live stream. And up until the last few years, PCs didn't have enough quickness in their packet handling to receive a live stream. A live stream, at least in the Axia world, is 4,000 packets per second to make audio. That's a lot. Normal AoIP audio is typically about 200 packets per second. So each packet is about 50 milliseconds worth of audio. Whereas 4,000 packets per second, each packet is a quarter of a millisecond per packet with audio. So Eugene, I hope I've answered that a bit. Jitter is a bigger problem because jitter just means you've got to increase the buffer to receive good audio. If the buffer is smaller than the jitter, then you're going to have dropouts. You can't help that. So I hope that helps answer your question, Eugene. Oh, I got a thumbs up. Thanks, Eugene. Thumbs up to you too.
Okay, thanks again, Kirk, for all the information you shared. And I know that as we begin to move away from the XLRs and the punch down 66 punch down blocks, and now we're going to RJ45s and Cat 6 cable, this is going to be the way of the future, and we got to all learn how to do that without any problem.
I got to tell you, in my experience, I'm so glad AoIP came along, because to me, it's such a joy to build facilities using AoIP, much more so than using analog connections. I didn't really have a big love in my heart for sitting on an upside down 5-gallon bucket, punching down wires on punch blocks. I did a lot of that. I'm kind of done with that.
I always wondered why does it take a shorter time to punch down a 66 block than finding the 66-2? You can never find where you laid the 66.
I know. So. I've had to go through a dozen of them over my career.
Right. All right.
Take care.
Our next, we will not have a webinar next in April because of the NAB convention. So our next webinar will actually be in May, on May 17th. So mark your calendar for that. Thank you, everybody, for joining, and we'll see you again in May.